So, what is cloud computing? It's a term that you've definitely heard probably many times over the past 5 years or so. Well, cloud computing is basically a model. I think of it as being like a business model where we can enable on-demand access to a shared pool of computing resources. And these computing resources are things like networks, servers, storage, and all the applications and services that run on that infrastructure. The key with cloud computing infrastructure is that it's on demand and it can be rapidly provisioned and deprovisioned with minimal effort. And typically, we can provision these resources very simply by using some sort of self-service web interface or application programming interface, an API. That means that we, as the customers of cloud services, we can provision our own services, and we can provision that using our own self-service interface. There's minimal interaction required. I don't have to pick up a phone or send an email message or or sign some sort of lengthy contract with a service provider in order to provision infrastructure. I can just use my credit card, sign up for an account, and I'm ready to provision any infrastructure that I need to support my services. There are basically five different characteristics for any sort of cloud computing service. These characteristics are based upon the NIST definition of cloud computing. NIST is a national standards organization here in the U.S. that defines standards for different governmental entities. The first characteristic that defines cloud computing is this notion of a service that is on demand. In other words, the service is available as needed. We can easily sign up and provision services using some sort of self-service interface. The cloud computing infrastructure is also available via network, so it's broadly available. In the case of Amazon, if you've got access to the internet, you can provision services all over the world. Cloud computing providers generally aggregate their infrastructure into resource pools, and these resources are oftentimes shared amongst a group of customers. When you go to Amazon and you configure your cloud server, that cloud server is virtualized, a technology we learned about last week. That virtualized server is running on the same physical server as virtual machines from other customers. So those computing resources at Amazon represent a shared pool of resources that have been partitioned and that are being utilized by a broad group of customers. The fourth characteristic of cloud computing is this notion of elasticity, the ability to rapidly provision new services on demand. And when those services are no longer needed, we can quickly deprovision those services and give that computing power back to the cloud computing provider. And this is one characteristic that makes cloud computing very, very distinct from your traditional computing and on-premise business models. If my company were to go out and buy several pallets worth of servers from Dell, and I would provision those servers in my data center. Well, after I'm done using those servers, I can't just call up Dell and say, hey, can you come and pick up your servers? I really no longer need them. I bought and paid for those servers already from the manufacturer. I can't give them back. With the cloud computing provider, on the other hand, I can purchase a bunch of EC2 instances and use them for a very short period of time. It could be minutes, days, weeks, or months. And then after I'm done using those systems, I can give them back to the cloud provider and I'm no longer paying for them. And that leads us to the fifth characteristic of cloud computing. Cloud computing is based around a utility service model. When you buy electricity from the power company to light up your home and to power your TV and your computer equipment, you pay for that electricity based upon your utilization. And you only pay for the amount of electricity that you're using every month. The same is true with cloud computing. With cloud computing, there's no minimum commitment, and you only pay for the computing and storage and network resources that you consume each month. If you don't consume any resources, then you pay nothing. So, and that's very different than your traditional service provider model. With the traditional service provider model, you would purchase computing resources, like you might purchase a rack of servers, and that rack of servers is going to be sitting in a data center for a length of time. Well, generally you would commit to at least an annual or 1 year contract for those services. And oftentimes you're committing to a multi-year contract. And if you're not using that equipment, if it's no longer needed, you're still paying. You're still paying, based upon the terms of that contract that you negotiated with the service provider. So the cloud computing business model is very much like the energy business model in terms of I I I make no minimum commitment. I will pay for the resources that I consume on a monthly basis, no more, no less. The One of the key benefits of cloud computing is based on this characteristic of elasticity. When you think about when you think about purchasing computing resources for your business, traditionally what we would do is we would always try to make sure that we had enough capacity available, enough computing and enough storage capacity available in our organization. Because the worst thing you could do is like you run out of capacity when you really need it. If you run out of computing capacity or storage capacity, then your fellow employees can't get their work done because they can't run their applications or they can't store their data, and that presents a real problem. So generally in IT, we would we would try to figure out how much capacity we needed, and we would buy more capacity. We buy more resources that we needed at any given point in time. So we always had sort of like this buffer of excess resources available to us. But sometimes, our the business that we were in, they might launch a new product, and that new product would be really successful, and suddenly we found ourselves lacking capacity. So we would we would encounter sort of this what I call this stair step, um, this stair step acquisition of computing resources in our organization, where we would buy some IT computing capacity and storage, and then suddenly find that we were potentially under capacity, and so we'd have to have a difficult conversation with the CFO and CEO and tell these senior leaders that, hey, we need more computing resources. So we'd quickly go out and we buy more computing resources, and then for a while we would be over capacity because we didn't really need those resources. Maybe the business would experience a decline in its profitability, and so we would really be over capacity for a while. So the point is that traditionally in IT and in businesses, we followed this stair step approach to in terms of acquiring and installing our computing capacity. And at any given point in time, we are either over capacity or under capacity in terms of our utilization of those resources. If we were over capacity or under capacity, either scenario represents an opportunity cost, right? In the sense that if we're over capacity, we could, instead of buying more computing and storage equipment, we could have invested that money in better marketing and sales. On the other hand, if we're under capacity, now we're potentially losing business. Our fellow employees aren't able to get their work done. Maybe our customers are trying to access our website and our website is really slow because it's underpowered and we're losing business. So, there's a real cost at either over allocating or under allocating resources. And this gets to the key benefit of cloud computing, in my mind, the key economic benefit at least, which is that with cloud computing, because we can purchase computing capacity on demand, and then we can release that capacity very, very quickly on demand. Our cloud computing infrastructure can very closely align with the demands of our business. Instead of following this stair-step approach to resource acquisition, our resource acquisition very closely models the actual demand for resources within our business. Okay, well, I've mentioned a few times that cloud computing is really a business model. It's a way for us to deploy uh, computing and storage resources on demand. It's a way for cloud computing providers to pool those resources and partition those resources across a large segment of customers. Well, if you think of cloud computing as a business model, there's really three different ways or three different service models, ways that you can deploy a cloud computing infrastructure. The first way that cloud computing providers might be able to deploy or provide infrastructure is using what's called infrastructure as a service. The idea behind infrastructure as a service is that the cloud computing provider is providing all of the underlying physical infrastructure required to support applications. The cloud computing providers is providing the physical data centers with the climate controlled, secure. They're providing all the power and the networks. They're providing the physical computer systems on which our applications run. So the cloud computing provider is providing all the physical infrastructure. And then as a customer, we are providing an operating system and our applications. And we are responsible for the OS and the application layer. The second cloud computing service model is what we call platform as a service, or PaaS. With platform as a service, the cloud computing provider is providing all of the physical infrastructure, all the same infrastructure as the infrastructure as a service provider. Yet they're also providing the operating system layer. And generally, this operating system layer is exposed as a set of application programming interfaces or APIs. And then as customers, we're just writing code. We're building our application, and we're uploading our application code to the platform as a service provider. The platform as a service provider is then responsible for running our code. We're not concerned at all about any sort of underlying operating system or configuration of the operating system or configuration of the hardware. We don't even really necessarily need to know how the platform as a service provider is running our code. We're just focused on writing code and uploading it into the cloud, and the platform as a service provider is responsible for making sure our code runs properly. Okay, the third cloud service model is what we call software as a service. With software as a service, the cloud computing provider is providing the physical hardware, they're providing the middleware or operating system environment, and they're also providing the applications. As a customer, then, we're simply taking our data and uploading it or entering it into the cloud-based application. And then we drive the application. We can use the application uh, within our organization. We're not worried about the hardware. We're not worried about operating systems or writing application code. Everything is managed by the software as a service cloud provider. And there's many different examples of these of companies implementing these different service models. For example, infrastructure as a service, you got organizations like Amazon Web Services or Microsoft Azure or Google with their compute engine. Platform as a service, companies like Heroku, and you'll see things like Amazon's Elastic Beanstalk, where application developers can write code and then upload their code and let Amazon run it for them. And then software as a service, many examples of software as a service providers, companies like Salesforce.com, where they're providing a cloud-based CRM systems that organizations can use. So those are the three different service types of business models. And there are also different ways that we can deploy cloud computing infrastructure. The most common way of deploying cloud computing infrastructure is leveraging what we call the public cloud. This is infrastructure that I think of as being web accessible. This is infrastructure that lives somewhere out on the public internet. We could also deploy cloud infrastructure in what we call a private cloud deployment model. With a private cloud deployment model, an organization purchases purchases the physical equipment, runs it in its own data centers, and then creates what we call an orchestration layer, which essentially sort of mimics or mocks the sort of capabilities of a public cloud provider. The employees of that company then can spin up applications and create infrastructure on demand using some sort of self-service interface provided by the organization. There are some organizations in the Twin Cities that are using orchestration platforms like OpenStack to orchestrate infrastructure that lives in campus-based data center environments. And then the third cloud deployment model is what we call hybrid cloud. And hybrid cloud is really represents an organization that is using both public cloud resources and private cloud resources. And the idea is that there might be some use cases and there might be examples where running applications in the public cloud makes a lot more sense than running applications in the private cloud. Now, my sense and my feeling on this is that over the next 10 to 20 years, most applications will live in the public cloud, and very few companies will actually be implementing and running their own private cloud, and that's just simply because of the economies of scale. It's cheaper to run most applications now in the public cloud versus private cloud based upon total cost of ownership, if you calculate it properly. Also, the speed and the technological advances that are occurring in the public cloud are happening much faster, more frequently than technology advances in private cloud infrastructure. So those companies that are relying on private cloud infrastructure are just not going to be able to experience the sort of rapid technology evolution that's occurring in public cloud. I think there's going to be companies that have the resources to build their own private cloud and support it. Maybe there will be a handful of companies in the Twin Cities, companies like United Health, maybe Thomson Reuters, and a couple others that have the financial wherewithal to and need to run a private cloud. But I strongly believe that most other companies, the vast majority,